Hello, everyone. I'm sorry I cannot see you, but I hope you're doing fine, and I hope you can see me well. Welcome to the webinar, or actually overview of the course of AI and Advanced Analytics for actually healthcare fraud prevention, detection, and investigation. The purpose of this course is actually to teach you how you can leverage AI and most important and more recently, the newest tools that are on the block, mostly focusing on generative AI, agentic AI, and how you can use these tools to actually better analyze your data, better investigate the fraud, and better do your analysis and visualization. So that's really the purpose. For advanced users, we will also try to cover how you can leverage these tools to even build some machine learning models and detect different kind of fraud. So let me start. The instructors for this course were Alana Lavelle and myself. This is a 3-day course, and Alana will be covering the material on day 1. And she would be talking mostly about AI evolution in fraud detection, global healthcare fraud trends, medical audit regulations, beneficiary fraud schemes, some future detection methods, and of course, some specific fraud schemes that are appearing in US. And also participants will learn how they can leverage local audit rules, detect and prevent fraud, and how you can leverage the medical knowledge in order to better understand what's happening. And of course, later, when I talk about AI, how this information could be used in detecting fraud in a better way. Okay, I'll be covering the course on day 2 and 3, and I'll be covering basically wide range of things. I'll try to basically explain what analytics really is, what we mean when we say data analytics, because there are so many buzzwords. We will try to actually cover different forms of data analytics, including how to use different forms of data, how to use different kind of data analysis, preparation, visualization, how you can build different kind of machine learning models. We will explain actually what machine learning model is, how you can build one, what kind of data you need in order to build machine learning model, and of course, how you can leverage this. And of course, we will try to use few AI tools to demonstrate how you can leverage some of these newest AI tools to actually help you visualize the data, detect fraud, build machine learning models, and also building some kind of agentic AI to automate some of the workflow that you have in your work. So this is the high level what we will be covering. Right now, I'll go quickly through some of these aspects and provide quick aspects of the demo, what we were trying to cover here. So the whole idea is actually the kind of the 3 major areas is how you can transform your actually manual work that most of us are still doing. It's hard to actually escape from existing patterns of the manual work because we are so comfortable with this. But actually, we will try to show how you can ask your data questions in a simple English question, like you are regularly doing with GPT, but just, for any kind of questions, write my email, summarize this text, and so on, and how you can quickly visualize some of this data. We can also show how you can build simple machine learning models, both including classification models as well as anomaly detection models. And also, we will show you some simple examples how you can deploy some AI agents to automate some of the tedious, time-consuming workflows that you have in your work. Okay, you're all aware of different buzzwords that are in the world right now. So many people are using many different words, but some of these things mean the same thing. Some people are using AI, BI, data analytics, data science, machine learning, deep learning, generative AI, agentic AI, and so on. So this course will try to demystify some of these things. Some of the major areas that we'll try to cover, how AI, machine learning, deep learning, generative AI, and agentic AI are related to each other. We will try to AI as a broad field, and then going slowly and deeper into the area, we'll try to see how machine learning occur from AI, how deep learning is the outcome of specific forms of machine learning focusing on neural networks, then how generative AI was actually the subset of the deep learning that is focusing mostly on the text analysis, and of course, agentic AI as the subset of the generative AI that is focusing mostly on basically optimizing and automating different kinds of business workflow by accessing your internal data and accessing different kind of tools. You all know that, for example, if you ask GPT, you sometimes may upload some of the information, but you have the limit. You have some limitations. However, this agentic AI will enable you to not only upload much larger volume of data, but also how you can connect to your database and how you can connect to other tools to actually optimize and automate a lot of things. So we will try to show actually a few examples in this area as well. We will also try to cover how you can use different kind of prompting techniques to actually optimize your use of GPT, Gemini, Claude, whatever tool you're using. And we also try to show you that, for example, some of the optimal frameworks for prompting are around the CoStar, and we will practice some of this. Right now, I'll jump to one of the examples that I prepared quickly for you. And let me go quickly to... Okay, let me see where I need to go. Okay, here. Let me go to new chat. I need to go to my script that I prepared for today. Okay, cool, here. So one quick example that I wanted to actually show you is that if you, for example, right now, most of you are using GPT to provide you certain trends, to analyze certain things, but GPT is also able to read any kind of images and text and convert this into text. And let me just show you how this looks like. So let's assume you have a medical record that is scanned image. It's not text, but actually you want to ask GPT to actually, can you read this medical record, convert it into text, and actually help me understand how this medical record could potentially be converted into claim, and what potential, fraud schemes can actually originate from this kind of medical claim. So right now, I'm using GPT for 5.1 here right now. That just appeared a few days ago for those people that are not aware. But this is a paid version of GPT, and it's basically able to read images, audio, and it's able to actually recognize all the text from the image, which is basically scanned medical record. And very often we only have scanned medical record. Previously, it was not possible to read this scanned medical records in an automated fashion. Right now, with all these tools, actually reading and trying to actually understand what kind of potential medical diagnosis code and procedure codes could originate from this and comparing to actual medical claim, it's much easier job. And the whole process of detecting potential discrepancies is much easier. So this is, for example, what the GPT was able to read. Let me just go quickly to this one. The next question I may have for the tool is actually to provide me with potential diagnosis code that could be submitted along with this medical record. The reason I'm asking this question is because we want to understand whether the provider who submitted particular medical claim and this procedure codes, that this diagnosis code that are suggested here are aligned. And you don't need to do this, you don't need to make any decision just based on one claim and one medical record. But if you notice the discrepancy between what GPT is suggesting here and what is on the medical claim is very frequent, you know that provider is doing something irregular. So again, fraud is typically intentional deception of the healthcare system. And this deception is typically proven through trying to establish the pattern of particular behavior from the healthcare provider. And this kind of pattern is typically established by showing how frequent provider is doing certain things. So right now, you have potential diagnosis codes that could be associated with this medical record. You can also get potential or possible procedure codes that could be associated with this medical records. Right now, you can easily create an algorithm that will compare list of these codes with the codes that are actually provided on the medical claim and try to see how often there is a discrepancy there. Also, you can ask GPT to provide you all possible basically ways how provider can try to actually change some of this to create a fraudulent claim. That's another option that you can try. So basically, the question could be, what are the 2 to 3 possible fraudulent claims that could be submitted that will accompany this medical record? And GPT will provide you options what providers could possibly do. So as you can see, this is much easier than what people were doing in a manual fashion. You have to read everything. Right now, everything is read for you, and it provides summary. You just need to figure out what's happening. If you try to automate all this procedure like this through some kind of automated agentic AI, you can establish the pattern of behavior for a particular provider. So this is one example. Another example that I wanted to show to you is basically trying to detect particular type of schemes. You're all aware that cookie cutter is the scheme that is quite common, especially in US, that people, healthcare providers are typically trying to actually establish particular type of claim, and very often just replicating that claim over and over in order to actually fabricate some claims, but actually the claims may not be real. So I created some of the medical records, let's say 5 of them, and all of these medical records are actually generated with GPT. And what kind of questions I have here is basically that I want. I said I uploaded it, a batch of five medical records for the same provider on the same day, and I need GPT to analyze these 5 patient notes from Dr. Smith for the cookie cutter fraud scheme. And I'm trying to basically say you need to provide a report that identifies which nodes are similar to each other, what the specific similarities, and so on. So this is some kind of the things that will help me identify if there is potential cookie cutter fraud scheme. That's really simple fraud scheme, but actually if you are able to upload some of this information, whether through just regularly working with GPT or not, that would be a relatively simple thing to do. One thing that I wanted to actually share here, that many of you are using GPT in many different ways. So right now, many companies also do not allow you to use GPT. However, GPT has few options. Either you can use Enterprise GPT, or you can use GPT through Copilot. Or if you're using your GPT as a business, you also have an option to actually limit or actually stop any use of GPT for personalization. So for example, if you go here, so there is an option to actually limit training. Where is this? Data controls. Yes, data controls. Improve the model for everyone. If you turn this off, your data will not be used for training and will not be shared with GPT. So I just wanted to share this with you. But this is, for example, for the cookie cutter fraud scheme. These are, for example, high-level notes, what kind of things you need to pay attention to in order to figure out whether these submitted medical records are actually prone to be fraudulent or not. So please keep your questions written, because we don't have two-way communication right now. So please write them down on the side. And at the end of the seminar, I hope I'll be able to answer all of them. So this is one thing I wanted to show you. One thing that I also wanted to show, and I'm not sure, and I'll be covering this during the course, is the use of custom GPT. Very often, you know that sometimes uploading certain limitations through this link here is possible. But sometimes if you do analysis, you have to do this every single time. And if you have to do this every single time, upload the same document, that may not be that kind of convenient. And there are better ways to handle this. So if you go here to explore, you will be able to actually search for any kind of GPTs that people around the world are created. So you can actually search for, let's say, medical fraud and medical fraud analyst. And apparently someone already created some medical fraud analyst. You can actually use this GPT that is designed to deal with different kind of fraud detection, and you can chat with this tool similarly to you actually chatting to ChatGPT, and it will be able to, for example, you can also upload certain data and provide you the trends, how you can detect certain, for example, schemes, for example, how you can detect double billing. It will provide you the advice how you can do that. This is a GPT that is created by someone else. However, you can also create your own GPT. In this corner here, you have actually option create. And if you go to that create, you will be able to create your own tool, and by providing specific instruction. I will walk you through how you can create this, but for this particular case, I just wanted to show you that one basically GPT that I created for the course. And basically, I have this whole set of instructions here, healthcare. I named this custom GPT healthcare fraud investigator. And in this healthcare fraud investigator, I basically provide all description, what is used for, what the instructions, what kind of the data it's using, what kind of capabilities you need to have. And right now, after configuring this particular custom GPT, you can actually start uploading the new data, or you can use the data that is already uploaded into system to help you with different kind of the healthcare fraud detection schemes. So this is one thing that I will cover during this course. And this is custom GPT is the concept of RAG, retrieval augmented generation, which basically allows you to use your own internal data when you communicate to GPT. The similar kind of capability you can find in, for example, for people who use Google Gemini, you can use in Google Gems. Also, Claude has kind of similar capability. So all these kind of the custom created GPTs or LLMs you have across multiple different tools. One option that they also wanted to provide to you, or actually explain to you, that sometimes people often ask a question, what is the best tool out there to do any kind of generative AI? So in order to cover this, I will also share some of the options. For example, I'm not sure how many of you use Perplexity so far, but Perplexity basically is the tool that allows you to actually have access to multiple tools and just paying one subscription. For example, in Perplexity, you can actually have access to Sonar, GPT-5, Claude, Grok, O3. So you can have access to multiple tools by basically paying only one subscription. In Gemini, you also have option for regular web search. Perplexity was one of the first tool that was able to actually search the web at the same time and do actually all kind of interaction and communication based on the web search. However, the Perplexity also have an option of the different kind of the deep research, and also it have option for labs when you will able to actually create any kind of the ideas and complete a document. For example, you just share what you want to do, and it will create a complete document, slides or dashboard for you. Something similar to the vibe coding tools that are currently very popular, but Perplexity has ability to do that. That's one option. Another option is to use OpenRouter. OpenRouter is another tool that have even bigger actually collection of the models that are available there. If you go there, you can see there are 566 models available here. OpenRouter works in a slightly different way. You actually pay certain amount of the credit, and you use this credit as you go, and you just use any different models that is available there. But every time you use a different model, you use a different pricing, and you use a different model for different things. There are also different kind of comparison sites when you can compare different models and see which one works better for which the purpose. And we will cover some of these things as well. So I just wanted you to cover some of these things that you are aware that you don't need to limit yourself just to one tool, but you can actually play with many different tools. I think okay.
Yeah,
okay.
that's the one.
Yep, got it. So the next thing I wanted to cover is actually what kind of the data sources you can use in your fraud investigation. In addition to just regular medical claims data that are typically used, you can actually use, as we saw already, medical records data. You can use evidence of care. You can use historical fraud data. But if you expand your horizon beyond your internal data within your insurance company or the government organization, you can use different kind of external data as well, especially today, including social determinants of health, web, social, and medial data, social channels, clinical guidance, pharma data, NPPS data, which is actually National Directory for Providers, and so on. The course will provide you some kind of guidelines, some suggestions how you can use some of this data in most effective way. So the whole idea for this course is actually to show how you can convert the old paradigm of doing fraud investigation, which is time-consuming, manual data analysis and providing limiting insights and relying on the data analytics and data science team, to something that you can do pretty much yourself. You can do basic data analysis and data visualization yourself. You can do this at a scale. You can try to automate some of this work yourself, and you will be able actually even to build machine learning models yourself without relying on data science. I mean, I'm data scientist by training. Actually, I have a PhD in machine learning. And when I discover some of these tools, these tools were able to replace months of work in a matter of days. So instead of basically being afraid for my job, I actually went there and learned how these tools work, because that will basically make me to survive. And this is actually what we're trying to do as well. We basically try to use all these tools to make sure that we can see some new activities, that we can try to predict some of the fraudulent activities. We can try to automate the work, and we can try to actually combine all this together without actually any need for coding. Even if you don't know any coding, you'll still be able to do a lot of this analysis. So the first thing that we will cover is some effective data visualization. We will show actually what are the key aspects of effective data visualization, that when you actually have to share some of your findings with your superiors, with your executives, and actually how to show it in a most effective way when someone is doing fraud. So we can show basically what this means and how you can do it. For example, some of the things that we can share, we can show basically how you can show these things on the map, how you can visualize some kind of the network graphs. And this is exactly what I'll try to do in the next demo here. So typical fraud ring is the situation when fraudulent healthcare providers are sharing a lot of patients together. And the more patients they share, the more suspicious their activities are, especially if one of these providers are flagged for fraud. And if they share a lot of particular patients with another provider, that makes that provider suspicious as well. And the best way to show this is through showing a graph like that. When you actually see the graph where actually two providers, for example, P1 and P2, are sharing a lot of common members or common patients. And I'll show you right now how you can easily use one of the tools to actually create graphics like that. Previously, in order to create graphic like that, you needed at least 2 months development from a data scientist. Right now, everything is possible within a matter of a day or two. So let me just quickly go through this example. I'll switch to the tool called Julius.ai, and I'll create a completely new chat, and I'll try to walk you briefly through actually the analysis, how this can be done. Okay. This is my script here that I'm preparing for this overview. And I'm using, actually, let me just show you here. No, that's out here. I'm using the public data set, which is called Kaggle Competitions. There are kind of 8 files there that are provided. And this is a data set that is anonymized Medicare CMS data, medical claims data, and is generated to actually different people to see how easy they can detect the fraud. There are like 8 files, inpatient data, outpatient medical claims data, There is beneficiary data, which is basically the data about the patients or the members. And there is also a data set that shows which healthcare providers are flagged for fraud. And you use this data set of flagged providers to actually learn and train your model. Then you can detect which of the healthcare providers from the test data will be flagged for fraud as well. So this is some public data set that I found that it shows like a typical features of the medical claims data, and I used in most of my demos as well. So going back to the demo here, I'm going to the Julius. I'll try to actually upload this file. Okay, I'll first upload one of the files there from these 8 files, and this is inpatient data, which is basically medical claims data for all the patients that stay in the hospital. And as you can see, as you upload the tool will automatically provide a summary of what this data is, the first like 20 records or so, and it will provide all the features. So you will be able to easily see all the information. As you can see here, instead of uploading the data, you have an option to connect your data to the database. If you click here, you will be able to connect to different kind of database sources. You will be able to use the different kind of tools. You will be able to do different kind of analysis, automated analysis. And you can also select a different kind of model as well. So Julius also support different kind of models. So instead of doing all these kind of things, we will just provide a simple query, or actually simple question. Can you read this file and try to actually clean all the duplicate data records? This is very often the case when you have the data and you need to clean the data for any kind of the errors. And the tool will be doing this pretty quickly. As you can see here, on the right side, it's providing you the plan, what is intending to do, and it will also provide you the progress, how quickly it will be doing this. One advantage of Julius.ai over GPT and other tools is actually that will not only actually create the code for you, but it will also run the code for you, because it provides you a mini sandbox environment that you can test it. Most recently with GPT-5 and 5.1, some of these features are available in GPT as well. But still, Julius.ai is still better when you have to deal with actual data. Actual data could be provided through Excel, just regular Excel file, like you're doing most of the time. But also, it can connect to different kind of databases. It supports, for example, Postgres, Microsoft SQL Server, and so on and so on. So as you can see here, this kind of clean data is provided in the file train inpatient data. You can actually download this file if you want, and you can provide here and download this file as well. So one other option I wanted to show, basically, one quick thing that you can actually always do is, for example, give me the number of distinct values for particular variable in this file. For example, there is a variable claim admit diagnosis code, which is here. Claim admit diagnosis code is basically a proxy for diagnosis code. And I want to see basically how many distinct diagnosis codes are appearing in this file. And because I want to do some analysis later out of that. So this is one kind of typical question I may ask the tool, but the sky is limit, really. You can ask any questions. The only kind of piece of advice I can share with you is to be specific. Try, if you have complex analysis, try to split this complex analysis into steps and do step at a time, because if you do multiple steps, the tool may be confused. So that's my personal advice, how you can make sure that you will get actually the best results. So out of this file, I want to create a new file right now, which is called diagnosis code histogram. And I want to create a new file that will actually create the file in the following way. So basically, for every occurrence of the claim admitting diagnosis code, I want to see how many times this code occurred, and also what's the total paid amount for all of these occurrences. Because sometimes this may be important. If you want to, sometimes even if you analyze diagnosis code or procedure codes, sometimes particular procedure codes are more prone to fraud, and doing this kind of analysis could be important from particular sense. So that's why I think I'm asking these questions. And this is basically how this file looks like. You have a diagnosis code, it occurred 2 times, and the total amount, insurance claim amount, is 21,000. For example, another code, 00845, appear 48 times, and the total amount is 436,000. And you have this file. We can actually download this file in the same way as before. Oops. I click something. I want to remove this, hide voting. Okay, so what I want to do right now is to create a simple diagram, simple histogram. And I want to create actually 2 graphs next to each other. And let me do this while explaining what I'm doing. So basically, I want to create 2 graphs next to each other. The left graph should provide the histograms for basically for the diagnosis code that occur the most, and I want to rank them. The right graph should provide the histogram bars for diagnosis code that we paid the most, because that's also important aspect as well. And I want to actually rank order this histogram or bar charts. So by just providing these kind of simple instructions, and again, try to be as specific as possible, because otherwise the tool may not provide exactly what you need. So the tool is doing this analysis right now, providing left and graph, and you can see, wow, it already created this. So these are the top 20 diagnosis code from the perspective of number of occurrences, and these are top 20 diagnosis code from the perspective of total paid amount. How much time you would need this to do this if you want to do this in a manual fashion, honestly. So this is one example of what potentially you can do. Okay, let me show you another example that I think it's quite powerful. Anytime when you want to leverage or show, okay, give me a second. Okay, anytime you want to leverage or show any kind of providers on the US map, this tool also provides this option as well. You can actually plot the US map relatively easily. You just need to say, could you draw the map of US where each state will be shown and marked with the borders between the states. Very often you need to actually pair this analysis with something else. For example, how many times or how many providers you have per state, or how many activities you have for particular state, especially with suspicious healthcare providers in suspicious space. When I was actively doing healthcare fraud, there were 4 states that were pretty notorious for fraud. These were California, Texas, Florida, and New York. These are the 4 biggest states, but also the 4 states where actually you have the most fraudulent healthcare providers. So right now, okay, I'm not sure if it did something wrong or not. Sometimes the tool may not provide all the results that you want immediately. Sometimes you have to repeat. But let's see if it will do the work for us. It didn't acquire US geometries. I just checked this an hour ago and it was working fine. So let me try again. It was trying to provide the error. It's still working, okay. No content. Okay, still working. The US geometries and US map JSON file is already in the Julius.ai, and it should work. If for some reason your installation, your copy of Julius.ai doesn't have that, you have to find that JSON file of the US map, upload here, and ask the Julius to actually draw the map based on that. The same thing if you're not in US. I just recently had a course in United Emirates, and I was able to actually upload the JSON map of the United Emirates, and actually the tool was able to show that map as well. And also, sometimes certain countries have certain regions, states, and so on. It's able to actually load all this information and plot the information based on that. So let's see. No content, it seems. That didn't work. Let's try again. If not, I can just show you what I did an hour ago, and I'll try while trying to fix this error. I know that our time is running fast, and I'll try to rush things in the last few minutes, but I just want to show you all potential capabilities of the tool. So you can play maybe on your time, or actually you can sign for the course and learn more. So if this doesn't work, I'll try to show you just what I did in the last hour or so. Okay, let me stop this. Stop this, and I'll open the chat. Okay, here. Okay. So this is the map that I created of the United States. I uploaded the file state histogram, where basically each state has particular data, for example, number of providers and so on. And the tool was able actually to show the map of the US, where basically the color of the particular state would correspond to the number of healthcare providers you have there. So this is one analysis that I was doing before. One thing that I also wanted to show you. Okay, I also have the data train inpatient data. So basically the train inpatient data that we created earlier, that we cleaned it, I uploaded here, and I wanted to create a file that will have the following structure. For every member, which basically members is defined through variable beneficiary ID, and providers are defined through variable provider. So I need to generate the file that will have all pair of providers who have a common patient. So the file will have three variables: provider 1, provider 2, and the number of common patients between provider and provider 2. So these are the three variables I want to have. So basically, this is the file that I am analyzing, and this is the file I'm generating: provider 1, provider 2, and how many patients these two providers share. So right now, what I want to do with this file, I want to detect providers that have a lot of common patients together. And I don't want to focus on, just, providers who have a 1 or 2. I want to actually have at least kind of 15 patients. And I want to create a graph that will show that. As you can see here, the initial attempt was not that great. And, you want to separate these providers. So basically in this kind of graphic, or this kind of in this graph, every provider is a node. And all these providers who have at least 15 common patients should be connected to each other. Right now, you see that this graph automatically was not that great. And if I go here, I'll see basically that after providing specific instructions, I was able to select, actually separate these nodes. And every time when a particular provider is connected to another provider, I want to actually, in addition to actually having the edge or connection between, I want to actually the thickness of that connection to depend on the actual number of providers. And I also want to share this number of providers here in the graph. So imagine what kind of the effort you would need in order to provide this graph just with some manual analysis, and even with the help of data scientists or data analysts. There were some specific tools for creating this kind of social graph analysis, but right now, for example, Julius.ai is able to create this kind of graphs by itself. So can you imagine what kind of analysis, what kind of things you can do with this kind of tool? Also, I wanted to share pretty quickly, let me jump back to this slide. I wanted to show also how you can use some of this analysis, machine learning, to actually build machine learning models as well. So let me jump back to Julius. I want to show you what kind of analysis I did as well. So as I mentioned earlier, the initial Kaggle financial data set has 8 data sets. So in this analysis, I'm trying to upload all these 8 data sets, and these are not small data sets. Some of them are 10 megabytes, 20 megabytes. This file has 80 megabytes. So it's not simple. It's not something that, even Excel will struggle. I think train outpatient data has like 80,000 data records. It's not that easy. So basically, this tool is able to actually handle a large volume of data as well. It's not just for the playing, for the kids playing. And in this text, I'm trying to explain basically what these data sets are. I'm trying to provide a role for this tool. You're a data scientist working for healthcare insurance companies. Your role includes building predictive models, such as classification models for detecting fraudulent providers, building anomaly detection models, and suggesting different business rules that will capture some fraudulent providers. So by providing more and more these abstractions, I'm actually trying to guide the tool what kind of analysis we need to do. One of the first analysis we need to do, we need to actually convert the medical claims data into the data at the provider level, because we detect fraud at the provider level. In order to detect fraud, data at a provider level, in order to detect providers or detect fraud at the provider level, we need to actually aggregate the data. So basically, for every provider, we need to generate particular kind of statistics, particular kind of the information. And this is exactly the next step that we are trying to do. We are trying to create a new data set that will merge inpatient and outpatient medical claim data and aggregate some of the information. We want to, for example, calculate total number of claims for each provider, average number of claims for provider, basically the average value of insurance claim reimbursed at the variable, and so on and so on. And the tool is able to actually calculate all this information, create completely new data set, and actually right now we want to append the information from the train label, which basically has only one basically file, has the information about which providers are flagged for fraud or not. It's able to actually merge this data set and create something that will be used for building machine learning models. So as you can see here, when you build these machine learning models, it will be able to give you simple confusion metrics, and we will learn what that is. It's basically one of the metrics used to evaluate the performance of your machine learning model. It's actually even explaining what this is here. It will basically be able to give you standard classification metrics like precision, recall, accuracy, F1 score, and so on, and explaining what this means. And also, it's trying to build and apply these models on completely new data set that you will see on a daily basis. So this is, for example, how Julius is able to predict whether certain healthcare providers will be committing fraud or not. For people and for companies that do not have the labels, we can also use this tool to build anomaly detection tools. And this is something that we are doing here. One model that we chose to use here is a local outlier factor. And we are trying to build this tool here as well. So we will all learn this in this kind of the course, and you will be able to build the models like any good data scientist. So, oops, sorry.